Section 4.4, more equations and applications. This is more applications about the use of logarithmic functions. And that's what we have been learning. What we covered in the last two sections was about logs and their applications. So to be able to apply logs even more, let's recall the either the rules or the properties of logs. The first one, I put it like this as a check mark, as the definition of log. Log x base m or base a equals m. This is the same as a to the m equals x. That was the main definition of logs. If we have log the product, any base, say base a, it's log x base a plus log y base a. Next one, log the quotient x over y base a. This is log x base a minus log y base a. Log y minus a base a. The next one, which is also good, is this one, log x to the m base a. This tells us that you can bring the exponent down like so. How do we apply them again as we did before? Let's see how to solve. Basically, we need to answer one question: how to solve equations. Either involving logs or not. So sometimes you're given an equation to solve, it doesn't have log in it, but you know you need to use logs to be able to solve it. Let's look at the easy example. Log x base 3 equals 2. So how do I solve such equation? First thing is, this one looks like straightforward using the definition. So if I do 3 to the second power equals x, so this means x is 9. Done. Is that the answer? Is that the solution? The answer is yes, that's the solution. One thing to keep in mind before we move further in this, just recall from before, if you remember, log any function f of x base a. This we need to make sure always that function f of x always bigger than 0 for all x, no matter what x is. Keep that in mind. So this answer that I got 9, if you put it back in, you get log 9 base 3. That's really 2. So the number I got is not negative. So it's okay for us to substitute that into the log function. Let's look at another example called example 2. Log, let's make the base x equals 2. So how do you solve something like this? Again, definition of logs, x squared equals 25. Remember, x squared equals 25. So what is x? X is supposed to be plus or minus 5. But remember, from the main definition of logs, so if I scroll back up here, just to recall, a must be bigger than 0 and it can be 1. This is very important. So we can't have negative base, for example, and it can be 1. So that's what we are going to see here. Wait, x is the base here, so it can be negative. So that's why x equals 5 is the only solution, not negative 5. What about if we if we write something different? Let's say w minus 2 plus log w minus 1, the same base 6 equals 1. There are several ways to solve such equation. First method, we can combine the ones on the left side. So there's an addition. The addition, it becomes multiplication, w minus 2, w minus 1 equals 1. Now I can use the definition of log. 6 to the first power equals w minus 2 times w minus 1. So now how do we solve such equation? Some students think like, hey, I can take w minus 2 is 6 and w minus 1, 1. But there's so many other options. Maybe w minus 2 is negative 2, w minus 1 is negative 3, w minus 2 is negative 1, the other one is negative 6, or it could be 1/2 and then 12. So there's so many options to list them out. The easiest way to do this is multiply, clean up the parentheses first, because if it was equal to 0, then it's done. But it's not, it's equal to 6. So let's multiply this FOIL it or multiply it or distribute it, whatever you want to call it. W times the whole thing minus 2 times the same thing equal to 6. Distribute this with this, that's W squared minus W minus 2W plus 2 equals to 6. Always when we solve quadratic equations, we make sure that this is set equal to 0. So let's keep this here as is. These two can be combined to become minus 3W plus 2. Subtract 6 on both sides. Then W squared minus 3W minus 4 equals to 0. On the left hand side, we can factor this one out because it's already equal to 0. And if you try the factoring by trial and error, 4 could be 2 by 2 or 4 by 1. So 4 by 1, minus and plus. Then W minus 4 is 0 or W plus 1 is 0. So what do we get? W equals 4 or W equals negative 1. Now this is a problem, like an exercise in the book as a homework problem. You look in the back of the book, you say, wait, they only marked 4 there. How come I got 2 answers and they only have 1? Well, remember, we need to check the answers. So if you have the 4 and then you want to go back and substitute into the original equation, it's okay to put 4 here. You get a 2 and here you get a 3. And if you multiply them, you're going to get log 6 base 6, which is 1. You can try it. But if you take the negative 1, plug it into the first one here, that's going to give me negative 3 right away. That's not possible. Log doesn't take negative values. So that's why negative 1 is not acceptable. Only W equals 4 is an answer. Let's look at another example. Let's say ln of x plus 2 equals natural log. I say ln, but I'm trying to use natural log instead of saying ln. Now, let's look at something like this. What can we do here? I can't combine like terms here. I don't have like terms. But what I can do is I can multiply these together as ln times x times natural log of x times x plus 2 equals natural log of 8. And we tell the students, like, you can drop ln, but usually, like, mathematically, and I'm gonna erase it, it's kind of like e both sides, like that. E ln of anything is the thing itself, and e ln of 8 is 8. But some students, they look at it like, hey, I can drop ln on both sides, but mathematically it's wrong. So now what we need to do is multiply this out. You get x squared plus 2x equals 8. How do we solve such equation? I got a quadratic equation. Quadratic means always set it equal to 0. So x squared plus 2x, subtract 8 on both sides. Then we have x plus 4, x minus 2. Set that equal to 0. Then you get x equals negative 4 or x equals 2. So let's see, if I put 2 in, that's fine. If you put the 2 in, fine, but the negative 4 is not fine. So this one doesn't work, only this positive case works. Let's look at another example. Let's say example 5. Log of 6 plus log x equals log 3 minus log x. Always, as I mentioned earlier, are there any like terms that I can combine? Oh yeah, this one and this one, they're like terms. So what I'm gonna do is add log x to both sides. Log x to both sides. So this stays the same. We got 2 copies of log x, and this stays the same. Now I can't multiply the first 2 together. So what I'm gonna do instead, I'm gonna move the log 6 to the other side by subtracting log 6. So that gives me log 3 minus log 6. What's next we have? What do we have? So on the left side, I can bring the 2 up here. So that gives me log x squared. Here I can divide 3 divided by 6. And 3 divided by 6 is 1/2. So why did I bring the 2 up? Because now I see log something equal log something. From the previous section, if you have log anything equal log the other thing, these two things can equal to each other. So x squared is 1/2. So what is x then? X is plus or minus the square root of 1/2, which is plus or minus the square root of 1 over square root of 2. Plus or minus 1 over square root of 2. Now notice, going back to the plus or minus, x cannot take negative values. So only the positive value. So only x equals 1 over square root of 2 works. And you can rationalize this. You can rationalize it. What about looking at different example? This example, 3 to the x equals 5. This has no logs at all. So if you are taking a test, then you're saying, wait, there's no logs or ln, so who cares about log or ln? The answer, the thing about this, no, we do need to care about this. What makes this difficult is having the variable as an exponent. So in order for us to be able to solve such equation, we need to find a way to bring the x down to the front. And the only way to do this is using logs, logarithmic functions. So how do we use the logarithmic functions here? We're going to take log both sides. Watch this carefully. So I'm going to take log both sides. One thing important to know, and you can use it or you don't have to use it, it's up to you. We did log both sides. This means I did log both sides base 10. That's what this means. Log both sides base 10. So what I'm going to do here is, can I take a different base? The answer is yes, you can have a different base. So I'm going to show you both of them, both cases. So if I keep it like this, I'm going to bring the x down, log 3 equals log 5. And then I'm going to divide both sides by log 3. So log 5 over log 3. And then you can put that in the calculator, and the calculator give me 1.4649. That's the answer, which is fine. It's okay. Or what I'm going to do, I'm going to rewrite this. 3 to the x is 5. I'm going to take log both sides, but watch what base I'm going to do. I'm going to do base 3 because the variable is only located where the 3 is. So base 3. So this means when I bring the x down, log 3 base 3 equals log 5 base 3. Log 3 base 3 is simply 1. So you get x equals log 5 base 3. And guess what? This answer and the one I got, they are the same. If you remember change of base formula. So if you like, if you can't put this on the calculator, you can do this as rewrite as log 5 over log 3, which will give us the same answer, 1.4649. So do you see the difference? So you can do log both sides base 10 or log both sides base 5, log both sides base 3. But the reason I did log both sides base 3 because that makes this part easy for me. I know it's 1, so I can simply get rid of it. But what about if the variable is on both sides? What base should I take? So something like this. In this case, should I take log base 2 or 3 or 10? Well, it's up to you. You can do base 2, base 3, base 10. You will get the same answer. Here I'm going to just take base 10. So we do log both sides, automatically means base 10, because most calculators are programmed base 10. Bring the x down, log 2. Bring the x minus 1 down, log 3. Now this step here, there's something important to know that I'm going to write here in red. You must wrap this with a parentheses. Put a parentheses around this. So this tells you the whole x minus 1 is being multiplied by log 3, not just the 1 itself. This is important. So now what I can do is get rid of the parentheses here by multiplying this x log 3 minus log 3 minus log 3. Now how am I going to solve for x? Can I divide both sides by log 2? You can, but then they will keep an x. There's another x here. So what I'm going to do is I'm going to subtract x log 3 on both sides. I subtract to bring all the x's to one side. And that's how we usually solve most of the problems in the, in the standard equations. Get all the x's to one side. By doing so, now we're gonna factor. We factor x out. That will leave log 2 minus log 3. And the right hand side stays the same. Then to get x by itself, you divide both sides by log 2 minus log 3. And that's the answer. That's the answer. You can put that in the calculator. If you do put that in the calculator, make sure you put a parentheses around this. Otherwise, the calculator will not understand it this way. So then what we do, you can put that in the calculator and see what you get. Or if you like, you can rewrite the denominator as log 2 over 3. So in this case, x, if you put that in the calculator, I got about 2.7095. Let's look at another example that has base e. So e to the x, or 2x, let's make it, equals e to the x plus 1. So how am I going to solve such equation? To do so, of course, we can do log both sides. But in this case, we're going to do log both sides base e because both of them are e's. Okay, you can do that. Instead of that, you do ln. Or another way to look at this, you say, hey, both they have the same base. I can just set the top equal to each other. That's another win. So here you can bring that down, 2x ln e. Bring the x plus 1 down, ln e. ln e is 1, so 2x equals x plus 1. Subtract x on both sides, that gives me the x value. Let's look at an application now. One of the applications is the half-life. It's called half-life application. Half-life application. So what is the half-life? Let's introduce this. So the half-life of a radioactive substance is the amount of time that it takes for one half of a substance to decay. So the half-life, basically, it's the time that it takes a quantity to decay down to the half. It becomes half the amount, let's say. And this is always modeled by the equation A equals A sub 0, or A node, e to the RT. What is A sub 0? A sub 0 is the initial amount, as we had it before. Before it was P sub 0 means initial population. R is the annual rate of decay. T is the time in years. And A will be the final amount, which will decay to half. So then what we have here, let's look at an example first. If the half-life of a drug is 12 hours, then at what rate is it being eliminated from the body? So it takes 12 hours for the amount to decay down to a half. What would be the rate here? Rate of decay. Well, again, this is A equals A sub 0 e to the RT. Remember, this initial amount is going to decay down to half. So it's going to become half the amount. So this is the final amount. the final amount is going to become half the original, whatever we started with. So it's going to become 1/2 a sub 0. And a sub 0 here, e, we are looking for r, and the t is 12 hours. Or, yeah, 12 hours. So now the question is, how do I find r? Well, you can divide both sides by a sub 0. This will go away, so 1/2 equals e to the 12r. Then natural log of both sides, natural log of this. Keep this the same. Bring the 12r down, natural log of e. What's natural log of e from previous sections? Every student should know this. It's 1, so that just gives me 12r on the right side. To get r by itself, you divide both sides by 12. And if we put that in the calculator, that gives negative 0.05. So you can say it's negative 5%. That's the rate. Notice how we used the rules of logs or natural logs here to finish solving for r. In general, you know, if you like to see this, in general, a equals a sub 0 e to the rt. That's the main equation. Remember, a is going to become 1/2 a sub 0. So that's a sub 0 e to the rt. If we divide by a sub 0, this will go away. And we get 1/2 equals e rt. If I take natural log both sides, natural log of this side, that will give us, this is natural log of 1 minus natural log of 2 by the rules of quotient rule, equals, bring the rt down, ln e is 1. Let me write it. So ln of 1 is 0 minus ln of 2 equals rt times 1. So if I want to find t or r, it doesn't matter. Let's say I want to find the time. Then the time is negative ln of 2 over r. This is a shortcut formula. Or you can say r is negative ln of 2 divided by t. You can solve for either one of them. So if you know this by heart, then usually, you know, you don't have to go through all this work. Because what I just did, I got ln of 1/2 over ln of 12. I know t was 12. So if I put 12 here, then it's done. Put this in the calculator, will give you exactly the same answer. So because ln of 1/2 is the same as negative ln of 2, or natural log of 2.